November 13, UPI creating fusion energy presents a variety of challenges, but researchers at Texas A&M University are closer to besting at least of the obstacles. Scientists have developed a new method for creating resilient materials possibly strong enough to survive the intensity of a fusion core. Fusion energy is the nuclear energy that powers the sun. One of the problems posed by fusion energy is the core is so powerful it would destroy most materials. The chief threat in a fusion core is helium. Fusion happens when two hydrogen atoms are fused to form a single helium atom. The helium can damage materials needed to build a fusion core. Helium is an element that we don't usually think of as being harmful. Dr. Michael Demkovich, an associate professor of materials science and engineering at Texas A&M, said in a news release. It is not toxic and not a greenhouse gas, which is one reason why fusion power is so attractive. When fused into metal, helium forms bubbles in an attempt to escape just as CO2 fizzes out of a soft drink. Literally, you get these helium bubbles inside of the metal that stay there forever because the metal is solid, Demkovich said. As you accumulate more and more helium, the bubbles start to link up and destroy the entire material. In labs at Los Alamos National Laboratory, Demkovich and his research partners observed the behavior of helium inside nanocomposite solids, metals comprised of thick layers. They found the helium formed long vein-like channels instead of bubbles. We were blown away by what we saw, Demkovich said. As you put more and more helium inside these nanocomposites, rather than destroying the material, the veins actually start to interconnect, resulting in kind of a vascular system. The channels provide an escape route for the helium without damaging the material. Researchers believe the nanocomposite metals could be used to build a fusion reactor. Researchers detailed the new materials in the journal Science Advances. Applications to fusion reactors are just the tip of the iceberg, Demkovich said. I think the bigger picture here is in vascularized solids, ones that are kind of like tissues with vascular networks. What else could be transported through such networks? Perhaps heat or electricity or even chemicals that could help the material self-heal.